Bright Tuty. Every student matters.
Find the nature of roots of the following quadratic equations. If real roots exist, then find them. Okay. So this is 2x squared minus 3x plus 5 equal to 0. So the discriminant is what? Minus 3 square minus 4 into 2 into 5. You can clearly see this is 9 minus 40, right? So this is lesser than 0. Hence we can say no real roots. Okay. So first of all you should say that discriminant is equal to b square minus 4ac. Then you should show that a is equal to 2, b equal to minus 3, c equal to 5, and then place these values here and show that this is a negative term, and you can say that no real roots, right? And in this question you don't have to go any further. Similarly, in this question we will calculate directly here, right, without discussing about a, b and c, because you can see you are comfortable with it now. So b square will be equal to minus 4 root 3 squared minus 4 into a is 3, c is 4, right? So it will become 16 into 3, 48. This is again 48, so it is equal to 0. So what was the condition? What was the nature of roots for d equal to 0? It was real and equal roots. And what were those equal roots? These were equal to minus b by 2a minus b by 2a. Okay, you can see once again the roots were minus b plus root d by 2a minus b minus root d by 2a. So if I take d equal to 0, this term will vanish, this term will vanish from here, minus b by 2a minus b by 2a. So what are the roots here? So the values of x will be equal to minus b, that is equal to minus of minus 4 root 3 by 2a, 2 into 3. Okay, so it will be equal to 2 will give us 2 root 3, 2 root 3 divided by 3. Okay, so both the roots are 2 root 3 by 3, 2 root 3 by 3. Okay, yes, right. Similarly for this one, discriminant is nothing but minus 6 squared minus 4 into 2 into 3. This will be 36. This is 24. So the discriminant is equal to 12. Hence the roots are x equal to minus b, that is minus of minus 6 plus minus root 12 by 2a, 2 into 2. So once I will consider the plus sign, once negative sign. So the roots will become 6 plus root 12 by 4 and 6 minus root 12 by 4. Now I can further simplify it because 12 can be written as 4 into 3. So 2 can be taken outside. So 6 plus 2 root 3 by 4, 6 minus 2 root 3 by 4. I can take 2 common and cancel it. So it will become 3 plus root 3 by 2, 3 minus root 3 by 2, right? So we have got irrational roots here, and these only difference in these two roots is this plus and this minus sign here. So these are conjugate roots. Okay. Okay, now we have got find the values of k for each of the following quadratic equations so that they have two equal roots, right? So it is already given in the question that the roots are equal, right? And when are the roots equal? When discriminant is equal to 0. So we just have to calculate the discriminant and put it equal to 0, right? So this is the condition. So what is the discriminant here? B square minus 4ac, which is equal to 4 into 2 into 3, should be equal to 0 as per the given condition. So k square is equal to 24. So k will be equal to plus minus square root of 24, right? So if I take 24 can be written as 4 into 6. So I can take 2 outside from here, 2 root 6. So k is equal to plus 2 root 6 or minus 2 root 6. So these are the values of k which satisfy this given condition for the quadratic equation this, right. Let us look at this quadratic equation. This quadratic equation is kx squared minus 2kx plus 6 equal to 0. Now we need to put discriminant equal to 0 because the roots are equal. Hence minus b, this is b, so b square minus 4ac minus 2k squared minus 4, a is k, c is 6, right. You should be able to see clearly that a in this question is k, b is nothing but minus 2k, c is equal to 6. So I have put b equal to minus 2k, minus 4, a equal to k and c equal to 6, and this should be equal to 0 as per the given question. Okay, so this is 4k squared minus 4k into 6 equal to 0. So what is the value of k? This is another quadratic equation that we have got in k. So now we have to solve this one. So what we can do is we can take 4k common from here, right. So k will be left here, minus 6 equal to 0. So this will give me k equal to 0 or k equal to 6. Now students, tell me, why can't we take k equal to 0? I am saying that this answer is invalid. Why? Because in a quadratic equation the leading coefficient cannot be negative, right. If I take k equal to 0, this will no longer be a quadratic equation, right. So k equal to 0 is ruled out. So k equal to 6 is our valid answer. So the answer is k equal to 6. Okay. Is it possible to design a rectangular mango grove whose length is twice its breadth? Let's say the breadth is x and the unit here is meter, okay, and length is twice its breadth. So let's take length as 2x, okay, and its area is 800 meter square. So the question is it possible to design such a rectangular field where the length is twice its breadth and the area is 800 meter square? So what we have done is we have taken the breadth as x and length as 2x, and now we will see that if we solve such a situation, x into 2x is given as 800 because area is length into breadth. So now what I've got is 2x square equal to 800, right, x square equal to 400. Now this question has been converted into a quadratic equation in x. Now if I get the real values for this x, then we can say that this field can be designed. If I don't get the real values for x, then we will say that such a field cannot be designed. Okay, so x will be equal to plus minus 20. Negative 20 we cannot take, x will be equal to 20. Hence we can say that there are real values of x possible, which is equal to 20, and the length will be 40, length 2x will be 40. So such a rectangular field can be designed, and this is the length and breadth is 20. Okay, if you want to go deeper into this process, what you can say is that you can make it into a quadratic equation, x square minus 400 equal to 0, right. This one, up to this place the solution is correct, right. But if you want to see it in the discriminant perspective, what you can see is b here is 0, right, c is minus 400 and a is equal to 1, right. So what is discriminant? It is equal to 0 squared minus of 4, a is 1, c is minus 400, right. So this will be equal to minus minus plus 400 into 4 is 1600. So the discriminant is positive, hence the real values are possible, hence such a field can be designed, right. Okay, is the following situation possible? If so, determine their present ages. The sum of the ages of two friends is 20 years. Let's say first friend is x years old. So the second friend will be 20 minus x years old, because their sum of the ages is 20 years. Okay, 4 years ago the product of their ages was 48. So what was the first friend's age 4 years ago? It was x minus 4. And what was second friend's age 4 years ago? It was 20 minus x minus 4, and their product equal to 48. Right, let's make this equation and see if there are real solutions possible. Only in case of real solution we can say that such a situation is possible, otherwise not. Let's look at this. X minus 4 into 16 minus x equal to 48. So this can be written as 16x minus 64 minus x square plus 4x equal to 48. So x square, this is 4x plus 16x, 20x minus 20x. I am taking all the terms to the right hand side. Okay, so this minus will become plus x square here, this plus 20x will become minus 20x, and this 64 we will add in 48. So what is 64 plus 48? X square minus 20x, this is equal to 112. Right, now we just need to check whether the discriminant of this quadratic is positive or negative. So let's see, discriminant here will be minus 20 square minus 4, a is 1, c is 112. Right, so this is equal to 400 minus, this is obviously bigger than 400, but let's calculate. This is 844, so minus 48, which is lesser than 0. So we can say that discriminant is negative, so there will be no real value of x, no real value of x possible. So if there is no real value of x, right, so such a situation is not possible. Right, such a situation where 4 years ago the product of their ages was 48 is not possible. Okay, all right. Again the same kind of question, is it possible to design a rectangular park of perimeter 80 meter and area 400 meter square? So there is a rectangular park, we need to see whether we can design such a park or not, where the perimeter is 80 meters. Let us take this breadth as a meters and length as b meters. Always take care of the units which are provided in the question. So in the answer you should not forget to write the units. So let's consider the breadth as a meter and length as b meter, and let's try to design such a park. So the perimeter is 80 meter. What is perimeter? Perimeter is the complete boundary. And how much is the complete boundary? It is 2a plus 2b. 2a plus 2b can be written as 2a plus b. It should be equal to 80 meter, right? And the area 400 meter. What is area? Area is length into breadth, is 400 meter. Okay, so let's solve these two equations and see whether we can design it or not. So a plus b becomes 40, right? So what I can do is I can take b equal to 40 minus a and put it in equation number 2. Okay, so 40 minus a is b into a should be equal to 400, and 40a minus a square is equal to 400. So if I bring everything to the right hand side, a square minus 40a plus 400 should be equal to 0. In this question, if you calculate the discriminant and value of discriminant is 0 or positive, right? Value of discriminant is non-negative, then we can say the real value of a is possible, hence the situation is possible. Okay, or you can clearly see this is a perfect, this is a complete square, right? This is 20 squared, this is a squared, this is 2 into 20. So I can write it as a minus 20 squared equal to 0 also. So real values are possible, but let's see from the discriminant perspective. So the discriminant in this case will be equal to minus b square, which is equal to minus 40 squared minus 4ac, with a is 1, c is 400, right? So this will become 1600 minus 1600, which is equal to 0, right? So the roots are equal, and the roots are equal to what? Minus b by 2a, which is equal to minus of minus 40 by 2, a is 1, right? So 40 by 2, 20. So the roots of this equation are 20 and 20. So yes, the real values of a are possible. Hence, it is possible to design such a rectangular park. So now we have got the breadth 20 and we can find the length easily now. So the breadth is equal to 20 in meters. Okay. So the length is equal to how much? B, A into B was equal to 400. So the length is also equal to 20, right? Because length into breadth was equal to 400. If I take breadth equal to 20, it will give me length also equal to 20. So yes, it is possible to design such a rectangular park, and this will be of the square form, right? A square is also a rectangle, right? But every rectangle is not a square. Alright. So yes, possible, and 20 20 will be the breadth and length. Okay. So this was about this exercise on nature of roots. Now we have completed all the topics that were in your syllabus in quadratic equations. In the next exercise, we will cover some important questions and some previous year board questions.